we're going to be investing 300 million in the city over probably the next 5 years. The whole idea is to create like the backbone of a decarbonised heat and power network, which serves a lot of key institutions, NHS, public sector, housing associations, industrial clients. And we're trying to really think about it like infrastructure rather than just straight up heat network.
Hello and welcome back to the Hypercube Podcast. I'm delighted today to be joined by Tunde Olaoye, Director of Product and Innovation at Gren. Thank you for joining us here in Glasgow. Would you like to just introduce yourself a bit and Gren for the audience?
Yeah, I'm Tunde Olaoye. I'm Director of Product and Innovation at Gren. So I've been working in the energy infrastructure for about 12 years now and started at Gren in 2023. Gren's a UK startup focused on heat networks, power networks, and at the moment, one of our biggest strategic cities is Glasgow, and we're doing a large project, which we'll talk about later.
Yeah, I'm excited to get into that because people in the office were quite stunned when they found out what it was and where it was and what was going on. But it's amazing having you here in Glasgow with us today to do this live. You've had a really interesting journey through energy, like straight out of Man Uni, a fellow Man Uni alum, so very happy, into Babcock, WSP, SSC. Do you want to just take us on that journey a little bit and sort of help us chart a course through energy to where you are today?
Yeah, so it was actually, you know, as well as I do, Manchester Uni was a lot of fun. And as I was getting to the fourth year in my degree, I was applying to quite a few different places. And for me, I was doing mechanical engineering, I did business management, and I just loved the idea of when you fuse them together. It was like that kind of catalyst of like, all right, I've got this design idea. How do I commercialize it? How do I build it? And towards the end of my fourth year and our final project, I was like, I'm too busy to do so many aptitude tests for like Rolls-Royce and BAE. And I was like, I just can't, I just need to go traveling. And Babcock was the first grad scheme, which was like CV, 2 interviews, and they offered me a job in April. So it was wonderful because I was like, I can go traveling and get a loan and start my job. But the grad scheme was in building service engineering. And I was a bit like, I'm not quite sure what that is because it's not one of my course titles, but let's just do it because I can go traveling and it's 4 placements across the UK and Babcock's a large company. So whatever, worst comes to worst, I'll just reset in a year. And it turned out it was a very, very useful place to start, but it didn't seem that way. So Babcock at that time had the infrastructure projects for the Ministry of Defence. So what they were doing is looking after all their infrastructure in terms of buildings, facilities, hard FM, soft FM, and one of their biggest pushes were trying to help decarbonise. So there's one in the southwest, and one in the east, and they had a lot of old building stock and obviously a lot of fossil fuel boilers and a lot of electricity that's being consumed in inefficient ways across their whole fleet, from some of their infrastructure in terms of how they manufacture tanks to just the lights in people's bedrooms. So I went into that company, worked there for 2 years. Did multiple placements, and it's quite an interesting place because it kind of taught me about first principles of engineering. It wasn't glamorous because I was on a 70s building site and everybody was really old and I just come from Manchester. I was like to my dad, I'm quitting.
This is different.
Yeah. I've been using laser machines and 3D printers and I'm out here and somebody's got like a normal printer, you know, the ones with the wheels on it with like the holes. So that was really cool, interesting, and it was at the time when a lot of the EU regulations were coming in around 2010 about EPCs, display energy certificates, energy performance certificates, and really thinking about how do you regulate the built environment. So they were using that to kind of push through a lot of energy efficiency, energy upgrades, CHP, solar panels. So it just gave me a big overview of actually things aren't really made as well as you would think they are. They're not designed that well, and the energy systems that were put in from like 1970s are very hard to decarbonize and produce energy. So it was a very tough place to start. So that was kind of where I began my journey and did a few interesting projects. I was doing a solar cooling project, which taught me a lot about rather than just go straight to the answer, because they'd have like a planned maintenance thing where they say, right, this building's overheating. So we need massive heat pump system in there. And then I looked at it, I was like, it's overheating because it's got loads of big windows and it's south facing. Maybe we just put some solar film on it. Did the count, it's like, solar film cuts your heat loss by 75%. and it's about 90% cheaper than putting an AC system in.
Of course, yeah.
So it was one of those first times I was just like, get back to first principles. Don't always just have a tick box, because a heat pump's an easy thing to do at that time. So then from there, I had a fun in Babcock, learned quite a lot, but then I was like, okay, I'm moving to London now, and I need to kind of get into probably a bigger consultancy with a bit more reach, because I've probably learned as much as I can in Babcock, which is really good formative years and a lot of solid engineers I work with, and really great scheme. I got chartered and then went to WSP. So joined the energy team, and then that was really cool because obviously everyone was young, and I was like, okay, yeah, I'm in London. I work for a consultancy. I've made it now.
Yeah, that's it.
Drinks after work. Yeah, that's the way forward. And that was really cool because they had a smaller energy team, and that was really about, that's when I got to understand digital systems in the built environment. So they did a lot of work on automatic meter reading, and measurement and verification systems and BMS optimization, as well as using software like IES to kind of thermally model buildings for the energy performance certificates. So in there, I did quite a few projects looking at metering systems, AMR systems, BMSs, pulling the data out, and then trying to use that to create strategic investment strategies for building portfolios.
Heat network.
Yeah, so you're looking at it and just be like, if you look at your cooling systems, they're running 24/7. Your cooling load is X. Your cooling system is sized to be Y. There's like a 20% delta in that, and it's not controlled properly because these are set points. So there was a lot of work with asset managers and landlords. So that was cool. That was just stuff's like a meter. It's a really simple thing. And I kind of feel sorry for the smart metering rollout because
It's a sore subject on this podcast.
yeah, I
Get
can
the
imagine. Yeah, it gets a bashing, but it's a weird thing because a meter is such a simple thing, such a simple instrument, but it's really quite hard to configure in multiple ways and make sure the reads are coming through and all the data systems that underpin it. It's like that simple complexity. So I learned a lot about sub-metering, AMR systems, and just how something so simple and so powerful to a certain extent can actually be quite difficult to implement. And OT systems are first before you think about the IT systems and the data that comes out.
Must be the first person that stood up for the smart meter rollout on the show.
Yeah, well, it's not great, but I feel their pain. Like I've done loads of some meter rollouts, and I'm like, if I was doing that across the country and trying to get into everyone's house, that's painful. That's painful. But we'll get there eventually. Yeah.
Maybe.
Let's not dig into that one then. But yeah, meters are difficult. We accept that.
Yeah. Okay.
And then after that, I joined SSE, and I was just lucky enough to join SSE at a time when they were starting to really, let's call it, flirt with multiple energy technologies. At that time, obviously, it was big thermal, it was trading, and it was their business energy, and they had residential at that time. So that was their kind of 4 pillars. And they started to look at EVs, heat networks, energy performance contracts, which is really focusing on like campus estates and local authorities saying you need to decarbonize your estate by 20%. What heat network? And how do I get like a 10-year payback? Or I want to reduce my energy consumption by 30%. How do I get a 10-year payback? You just redesign my building systems to achieve those goals. And then they were also looking at behind the meter solar. So it's quite a cool little place. We had a small little office in like Brahma House in London. Cool. And it was like, we were in SSE, but it was kind of a quasi startup because we were so small, like not even a rounding error on the SSE. Like, so we could just kind of get on with what we needed to get on. We had the SSE brand behind us, but we weren't necessarily having that oversight of SSE looking deep into it yet. And then all the different businesses start to scale independently and get slightly above the parapet. And over like 7 years, we went from like me and my boss, Kostas Papadopoulos, big shout out if he listens to this. He was a great boss and leader to get this started. And we basically started to bid into frameworks and then turn like zero revenue into like a team of 16 and eventually got to about 20 million pounds of revenue in terms of like EPC contracts.
So was that almost like an internal consultancy?
Yeah, sorry. Yeah, it was like an internal consultancy in a way, but we bid directly.
Yeah.
So we would go to like local authorities would have a certain framework called refit. And then universities and hospitals also put tenders out on that. And then refit had basically set up a structure where they'd have like measurement and verification plan contracts. They'd have like a structure of how you set your bid up, how you put your energy data in. So at least when everyone went to bid for those projects, they had like a contracting form that was accepted by both parties, because obviously I'm guaranteeing carbon or energy saving. So that's where normally the complexity came when people are trying to underwrite that kind of investment.
Yeah.
You'd have to spend loads on it in independent and a bespoke contract, whereas that framework allowed it. So we did some internal consultancy work for different measures like behind the meter solar and some of the heat networks team, but we were quite outward focused.
Really cool. Yeah. So you're building like services kind of arm to SSE, powered by the SSE brand and the Behemoth machinery that they've got. That's really cool.
Yeah. And it was cool because we just got to touch any technology, because our basically output was decarbonize or reduce the energy. So we could look at solar panels, heat pumps, control systems, LED lighting, HVAC. It was basically, you look at a building, just strip it back to its kind of individual energy streams. What are you actually trying to achieve? How does the people use the building? And then we redesign it for that, and thinking, all right, let's go smart lighting, let's get PV on the roof, let's change your control system so it integrates with your lighting system. So when someone comes into a room, your HVAC comes on, your lighting comes on. And then let's think about, in the future, if you want to decarbonize, what's the best route to do it? And not always heat pumps is going to be the best route, because it's going to be very expensive.
So like, feels like a thread of decarbonisation and of big building estates and big old kind of semi-public sector defence has been a thread through your career. Is that fair to say? And was that what sort of led you naturally towards Gren? Because you were at SSE for a while, right?
Yeah, I think that's fair to say. I think it was trying to decarbonise and reduce energy and suppose the harder buildings. You're not starting from scratch. You're looking at the existing stock and thinking about those challenges and how do you really think hard and deep and make this affordable. And exactly what led me to Gren, because my CEO now, Mike, used to work at SSE. So he used to be part of the heat network team. So he's in that small Brahma House office, and a few of us have stayed in contact over the years.
Cool, because like I naturally was going to say, but I'm aware of the questions I'm going to ask you. Yeah. Naturally, the next thing for me was like, I just wish we did more heat network stuff in the UK. Yeah. What a segue, right? So do you want to talk about some of the work you're doing and like the big projects up here in Glasgow?
Yeah, so Energy on Clyde is really cool. So what we're trying to be is, we're going to be investing 300 million in the city over probably the next 5 years. The whole idea is to create like the backbone of a decarbonised heat and power network, which serves a lot of key institutions, NHS, public sector, housing associations, industrial clients. And we're trying to really think about it like infrastructure rather than just straight up heat network. We're trying to think about how do you manage your energy flows and the source of the energy, as well as some of the key arteries of delivery. So we're just trying to think about heat networks differently, because often it's a bit of a chicken egg, because you're thinking to yourself, got to get contracts with the off-takers, but we've also got to capture the energy source and buy that at the right price, then sell at the right price. Whereas we're trying to think about it slightly differently. And a lot of the assets that we own in Gren are energy from waste plants or waste wood biomass plants. So we've captured kind of the energy source in the projects we have, and then thinking about how do we build the big bits of infrastructure that allow us to transport the heat and power to where it matters. So it's quite an interesting business model, and we're trying to think about it differently, because we really believe that, you know, clean energy should be affordable for everyone, and it can definitely deliver a win-win. So that's how we've been kind of building our business model and trying to kind of scale that out now to have that real focus on its infrastructure. It's not just a heat network. It's kind of as important as your water pipes are going to be, and also your fiber installation. I would say gas, but gas is going, so get rid of the gas.
And I suppose some of the people that listen to this podcast might not actually be too familiar with what a heat network is. Okay. Because it's a lot more common in the continent than over here. So if I'm like a hospital or a social housing stock, like why do I care about heat networks? Why, what, and how do I go about picking that over alternative approaches?
So the whole idea really is similar to your power network. Like, it wouldn't be great for everyone to have a little generator in their back garden making their own power. So it's better to centralize all of the generation of heat into one place, because I can get economies of scale by having a large heat generator, and that could be air source heat pump, could be water source heat pump, could be waste heat from industrial, could be from an energy from waste plant, could be the spare thermal from gas power plant. But the whole concept is, if I've got a hospital, for instance, a local authority, a bunch of housing associations, a big industrial user, they've all got their own individual needs. So the hospital might need a 20 megawatt boiler. The industrial users might need a 30 megawatt boiler, all the houses might need 50 megawatts. And if I combine them all together, I can get away with just doing a 60 megawatt boiler because I know that all their peaks won't be at the same time.
Yeah, okay.
I can use stuff like thermal storage, which is a super interesting, segue you can get into. But the most classic way of thermal storage is a large tank filled with hot water. So I can balance the peaks and loads. And if you do it correctly and you can co-locate lots of energy sources and a very effective heat generator, which utilizes the best energy source for that particular location, then you can effectively deliver low cost, low carbon heat to more users rather than one person having to front the bill for their own energy system and look at their fuel costs, look at their maintenance costs, optimize the system to make it work better for them. They can just connect up to what we would call like basically a heat substation, which is just a small heat exchanger effectively. They'll have two pipes coming into their building and then they take heat off that and then they pay per kilowatt hour, same as like the grid. So we put big pipes into the ground and effectively transport hot water through the city through two pipes, flow and return. There's literally like a little microcosm of the grid in heat networks. And you're right, our Gren is from the Baltics originally, and there's a lot of systems in the Baltics, a lot in Germany, a lot in the Nordics as well, because they learned from very early on because it's so cold that it wouldn't be, as efficient to be able to sell or build your own individual heat pumps and boilers for every house. So that's the kind of idea of a heat network, and now putting regulations in the UK to make heat networks more controlled and managed in the same way the electricity network is.
That's good. You said city there as well. Were you doing, because in my head it was always like either new build housing estates or like small isolated pockets on
Heat network.
industrial and commercial sites, but we're getting these like city centre heat networks happening now. That common?
That's not common fully. There are a few in the UK, but that's what we're trying to push now, to go to the level of saying, look, the way that we look at it is we won't do it all because you can't build a city scale heat network on your own. But what we want to become is like the transmission line, like the 132 kV cables. Like we want to be like, here's a big generation source. We can generate the big bits of infrastructure. We can finance the big bits of pipe. We can take it to the key locations. We'll have a connection to few big customers that we can contract with. And then we'll say, listen, new developer, new heat network operator, we've got a heat substation there. You can take a bulk supply of that and build your own mini network, or housing association here. We're dropping heat to this location. So you can connect up your houses and then we'll give you kind of a bulk rate to go and look at that. So our kind of model is trying to work with the whole industry and not think that we can do it all, but think about the most difficult part is getting the big bits of infrastructure of the generation and the big bits of pipe to where the clusters of use are. Once you've done that, then work with partners and different people across the industry to deliver.
That's really cool. And the reason I'm interested, I guess, is like being based in Glasgow, live in Edinburgh. I hear a lot about actually heat networks might be the only solution to decarbonise some of the lovely tenement flats we have. We've got these incredibly beautiful flats across the cities that you wouldn't want to touch or like stick air source heat pumps on the side of and things. People have said heat networks will be the solution, but it's a bit scratch head, not sure how to achieve it. And is that a vision for the future you see that's achievable? And is there anything more on energy for Clyde and what you're doing in Glasgow that you'd like to share some details on?
Yeah, no, that's definitely it. So I think for us, the whole idea would be if we can build a really interesting kind of infra model, then it's much easier for a developer or the housing owners to think, oh, you know what, I'm going to wait till 2029 because I know that the energy on Clyde pipe is going to be coming past our building at that point. And at that point, I can engage my kind of building service contractor and say, look, we want to do a kind of building level heat network, and then we can connect into it. So their model, and that's where we'll get interested in the future. And we've actually got a lot more digitization on our network. We'll be able to say, yeah, we've actually got quite a bit of spare capacity now because we've connected to that hospital, but they've done some energy efficiency work. So their peak is lower. So you can actually connect. If you connect in this date, kind of like an octopus model, give you this price, this is a connection charge, and then you can go manage your internal buildings. And then it's easy for them to kind of scale up and work out, okay, how much is it going to cost me to fit out my building? And then what tariff can I sell them? Because I know what tariff I'm going to get it from Gren. So that's the kind of model, and that's what we're trying to, in the future, build out to. But the first bit starts at like getting that core bit of infrastructure in the ground and kind of, we're kind of looking at it like we will put it in the ground and we will invest, kind of Kevin Costner, if you build it. They will come. Field of Dreams, heat network style.
I like it. And that touches on a point then. So like product innovation, it's not just new and clever ways to make stuff hot, right? You're actually financial innovation. Like, how do you bill for this? How do you evenly, like, a block of 8 flats, how do you divvy that up? And you're talking about digitisation, tariffs. Is that a big part of your role then, looking at the different ways actually this is going to be achievable for the customer?
Yeah, I think it is. I think you've got like, as we're in the investment world, you've got your base case, that you can always just say that we're going to do this. And effectively the idea would be we could sell it for X amount of kilowatt hour and X amount of capacity charges, and the investment will stack up and it will pay for the pipe and all the connection infrastructure. But the more interesting thing is really, we'll talk about a bit later, is like, how do you put like a digital twin on your heat generation source? And then how do you really optimize your heat generation so you can make it lower, or you can capture more heat from the same piece of pipe? How do you use digital twins to kind of model the flows in the pipe and to make sure that you've got it at the perfect, I suppose, velocity in the pipe versus the capacity? And then stuff like delta T, if you're going to get really deep into the engineering, really managing the delta T across the network so you can get, again, more heat out of the same bit of infrastructure. So let's just say we can build this and we can deliver really affordable energy to the people who need it the most. And then once you've got that in, you've got so many layers of digitization and optimization of the system and the network that you can start to think about more innovative products and kind of got one eye in the future. But some of the stuff is just, as well as, getting off the plans that we've got today, is sometimes quite difficult, just getting it out of the site and getting into the energy center and working out the space constraints where you don't necessarily know what your future loads are going to be. So there's a lot of kind of second guessing and thinking about optionality you can get from digitization, but trying to find out what's the one number you can build today that kind of works for today, but also gives you a bit of spare capacity. So that's kind of the place we're playing in. But Gren's quite flat at the moment, so there's lots of little things I'm doing across the kind of Gren portfolio, just because where there's a need, there's a must.
Yeah, change all the job space to just get stuck in and figure it out.
Smuck around.
No, and that was going to be where I went next, was digital twins. Like, you must have a load of, because I'm just like trying to figure out how would I do this if I was doing it myself. And you obviously start small, learn some stuff, get better. So you must be accelerating like your pace of delivery and learning. And you must have a load of like optimization and engineering boffins that are like bringing these insights together to develop these new products. Can we get into the weeds of, the digital twins and what you're doing?
Yes, it's a good thing. So like initially I was the boffin. So Sheffield, when we bought that asset, it had a control system that wasn't working as effectively as we would like it to be. And the site team effectively could not manage the availability, and they couldn't control the plant the way we wanted to. And obviously when it's a bonfire in a box, so controlling fire with waste wood burning, you need to have quite a good handle on your control system. So the initial thought process was, it's £1 million to replace this thing. So we're going in, changing the controllers, going into the full digital control system, automation, and looking at what's the control logic, is ladder logic. We're going to rip out all the PLCs. Do we have to put new safety systems in there? And we had a bit of a plan, had some engineering teams looking at this, writing a new description of operation, trying to work backwards and decode the system. And we found a company in Latvia who had this digital twin system.
Okay.
Which effectively is a way to read and write a control system. So OPC servers, ways that are built into a lot of SCADA systems, and it allows you, it's effectively an interconnecting protocol, which means that if you've got an OPC server installed on most SCADA, it's kind of like an open source protocol that if you understand the parameters and tags, then you can rip them out and put them into another system. So they developed their own kind of digital twin system where you could put an OPC server on, take all the SCADA tags, bring that into their own server. You'd have a small server on your site, like a Dell PC, with most of the processing capability, but talk to their offsite servers. Then they would map the process, replicate the SCADA system HMI on a web UI, so you can see the SCADA system live from any computer, then build some analytics on the data points that are inside the SCADA system, so you can look at like the temperatures in the boiler or the fans or the DP set points, like basically every IO you want to look into, you can look into. And it took a while to But when you get to 5,000, you're like, how many do you want? I was like, 5,000. Like, but it takes a long time to get 5,000. It's like, okay, let's go Pareto. Give me 20% that cause 80% of most problems. So then you rip those in, and then you can start to do analytics from that, because obviously if we know the temperature of the boiler, we know the fan flow rates, we know mass fuel balances, then we can start to calculate how much heat is coming out the boiler. We know the movement of, for instance, the pusher, actually the ram feeder, which pushes wood into the back of the boiler. Every time it pushes it in, maybe it pushes like 3-4 kilograms. So if you can take your historical data from how much wood got delivered over the last month, and then you look how many times the ram feeder moved, you can basically work out how much is pushing in, and then work out, okay, this amount of fuel's gone in, this is the heat mass balance, this is how much energy came out, and then you can do analytics. And then the final point is the machine's meant to control the machine. So every minute, once we've done the analysis on the boiler, understanding the heat mass balance on the boiler and how it can work at its most efficient point, primary air, secondary air, how you should be controlling like some of the recirculation fans, dampers, you can then say, okay, optimize it. So we use the lowest amount of fuel, but achieve the temperatures really required in this particular boiler. And every minute, the digital twin would then look at every setting, look at every important parameter, and then slightly adjust, for instance, the ram feeder, or it'll move up the primary fan hertz in zone 1 up to 2 hertz higher, because you're not getting enough burning in the zone because the temperature gradient's not right. So every minute it goes round and makes slight adjustments. So rather than normally when you have a SCADA kind of operator on these boilers, and it's also when it's fueled, it's kind of like, I just had a big bit of dry fuel gone in. Temperatures just spiked. I know after the fact, because my fourth temperature sensor has already gone up and it's breaching. So now I've got to kind of, whereas the digital twin will start to see those spikes incrementally and start changing secondary air to kind of cool the zone. So it's been an interesting, way to put technology in, and it's been a big learning curve for us, because we're at probably like zone 2, where at the moment we're pulling out all the analytics. We've got all of our boilers and all of our systems that generate power and heat now fully configured, so we can go anywhere. We call it Netflix, because on a Saturday night, I can be like, oh, how's the boiler doing? How much? Oh, what? 5.2 megawatts, love. Get me some wine. It's a big night. Let's go.
It's really interesting. So you're like a few insights, like £1 million to do that doesn't seem like a lot of money, actually. Like thinking about consultancy and doing projects and picking apart, because you're effectively reverse engineering like a piece of software that was written however long ago, like secret squirrel IP. You won't know how that was done or why, and you're turning that into like an actively managed, sort of continually optimized control system that you can scale digitally and learn from, and build up this wider portfolio of analytics. Because we do bits of optimization for lots of our customers, and I often like to talk about like the 1 in a million event. Like, how many 1 in a million events have you had? Probably not many, but scale it across a portfolio of assets, and you become really smart, and like you just kind of, the power of your analytics grows over time. It's a really cool approach to doing it. I'd love to like sort of see more under the covers of what you're doing, and have a look at some of that stuff, just because I mean.
No, it was, that actually didn't cost us $1 million. That was a price tag to replace the DCS. So doing this digital twin was significantly like in the orders of magnitudes cheaper to do that part. We had to spend a lot of money using very smart consultants to help us with the physics, and working with a guy called Darren, and he's really brilliant. And he was just like one of the areas that, which I didn't quite anticipate being one of the biggest value adds, is actually just the surfacing of the data. Because my thing was more like, right, we're going to get to the machine, running the machine, and we can optimize this thing. So I was like, let's sprint at this and let's go. And if we get that, then we don't need the people on site. But there's so many little things wrong with that boiler that weren't the control system. And when Darren came in, he was like, able to crunch so much data so quickly that he was being able to like, let's look at this, let's look at this. He talks about megajoules per second rather than megawatts, because he's like, in thermal world, I'm going old school. And I was like, wow, this guy's serious.
That's very cool. What other ways? So like, there's quite a whirlwind tour of like a really complicated system. What other ways are you using technology to your advantage?
Yeah, kind of building on that is, I think this is, as you talked about optimization, and I think this is sometimes where people get too stuck into the business case at the first stage, because there's a kind of this thing of like, it's corny, but once you surface this data, you can effectively build so much on it. And there's so many things you don't necessarily know that you can build into a use case. So one example is, at the moment, we've got these kind of operational management, can't remember what the A stands for now. I'm going to get told off my data analysis, but we call it an OMA tool. And because we've got the digital twin, one of our biggest challenges was our accounting team have to basically do accruals. So they're like, how much wood got delivered, how much lime, how many consumables are delivered, and all they can see is the end invoice. And when they know how much power is generated, we have to wait to the end of the month and go into like the Sentinel platform and then download that. And then there's so much data they have to do. So when it gets to the end of the month, if you think about a portfolio of lots of different biomass and power generation assets, they were literally just flat out. And then by the time they finished, it's the end of next month. So now with the digital twin, one of my data analysts has now built like a financial tool that sits on top. So we take all the digital twin data, we basically convert that into our P&L data from all that. So we know the cost per ton of fuel, we know the cost per ton of lime, we know what urea, how much gas we burnt for like secondary firing when we've gone down. And we've got this great Power BI dashboard now, which get updated every week. So every week we have a call with finance, they can look into it and they're like, okay, so what's the P&L looking like? Where are we? Oh, why we got this big shoot up in gas? Oh, because we had a failure here, or this thing happened, or the lime cost looks much higher. We've got an invoice for this, so how much we got in stock. And the whole thing is trying to compress down like something that takes, 10 days for them to do accrual down to effectively, it takes you basically half a day to do an accrual, because every week basically got all the numbers. And the only game is to keep on refining the OMA tool, because when there's a discrepancy, we just need to look at, do we need to recalibrate the model?
Doing your edge case. Or, that's really cool. And I think like that touch, I want to ask the AI question, but I'll get ahead of myself a bit. Like people always ask like, well, what should we be doing? What should technology do for me? And I genuinely believe like the energy sector is complicated and messy enough. You've got like financial world, physical world, you've got all this stuff trying to come together that you don't want the AI and the machine doing the thinking bit. You want it to do all the craft. Like get all the numbers and stick them into one table so I can just look at them and it's easy and read all these Excels and so on and so forth. So I totally see that kind of tooling, that OMA tool. It sounds like the kind of thing that we always think is one of the best first passes to go after. If you're in the BES world, like settlement of mixed portfolios, like, okay, how much did we say we were going to do? What did we do? Who gets paid what? It's really, really tricky.
Yeah.
So are you investigating AI? Is that like on everyone's kind of lips, or are you skeptical? What do you think impact is going to make at Gren?
I'm a user. I've made friends, with multiple GBT, Claude, all of them are little friends. I think it's a really interesting space. I always think of it like, I was chatting to my wife the other day because she just went back to work after a year of maternity. And like often, because we actually met at WSP, we were basically, big shout out to Arietta, by the way, I'll get told off. I didn't say that. Love of my life. So she was going back to work and I was like, listen, we always have long conversations. You come in because we work at home, and she's like, oh, what do you think about this? And ask me about this, and I'll explain something to her. And then we'd be there for ages. Like, you've got a new me now. You got ChatGPT, and like, don't look at it as just a glorified search function. It's like a calculator for like ideas and words, and you can bounce stuff off it. And like, what would take you ages before to go read lots of CIBSE guides or lots of like industry standards, you can go like, these are the core industry standards. I know that the information's in here, but rather than sifting through like 300 pages, put that all in, ask it the right questions and just get started. I don't think it's like, I can ask it to like design me a heat network for a city scale, where it can tell me like, right, thinking about the new regulations that are coming in, what are the areas I need to really consider when designing a heat substation? And then you get these ideas, it gives you a place to really focus, and then you can kind of jump into that. So for us at the moment, we're kind of looking at it and thinking, okay, where are the best use cases for it? How do we as a startup as well think about using it most effectively, but also take into account the risks and making sure that you've got a place where if you're putting your information, it's protected. You're not necessarily training the model and stuff you don't want to use, and having good policy. So put an AI policy out there. We've got our own kind of linked into ChatGPT, OpenAI, Gren version. So it's quite nascent with us. And one of the things that we'd love to do in the future is, now we've got this digital twin, we've got all this data. One of the operational team challenges is this pump's about to break. Yeah. Like, what was the spec originally and what do I need? Whereas if you had all this data and you knew the characteristics from the ET, you can say, what's the best size pump to achieve the flow rate that I require? And then it'd be like, yeah, these are 4 pumps. And this is a good supplier. That's on your supply chain system. So order from them. That's kind of what we're thinking about, how you can use it. But yeah, early days.
I'm in agreement. It's an interesting space, and you've got to, I think every industry's got to tread carefully. We're all still kind of learning. Like, people ask me, like, oh, what should I do in AI first? I was like, I don't know, just get going. Like, no one knew it 2 years ago. It's all new, this flavor of the technology. But looking at specs and parts, we did a piece that built like a recommender system, you know, like Netflix's, like, oh, you might also like this, or Amazon's, like, people also buy, or service call outs. So your boiler and your heat network off in the middle of nowhere goes down, and instead of sending someone to go to site, having a look and go, it's this thing, can I look at all the log data and recommend the top 3 failure causes? So your engineer turns up with those 3 parts in case it is one of the top 3, and then it massively reducing your kind of call out times, down times and stuff like that. And then seeing some really interesting stuff with LLMs interacting with optimization engines and stuff like that. We ran a community meetup up in Edinburgh recently, and we had Lars from Edinburgh Uni, who's a reader for optimization, like super boffins. Shout out to Lars. And he was, we asked the question, like, oh, is AI coming for your job, to everyone? And he was like, it can try. But his whole bit was like, you would have to either use the LLM to translate, like, the universe into the maths that the optimizers need, or the other way around, and both's really, really hard. So I think I'm safe for now. But there is some success in this space. It's an interesting place. And I think, like, it is only 2 and a bit years in, 3 years in. So we've got more use cases to come. No one's sort of shown a game-changing use case to the industry yet, I don't think.
No.
That stuff's coming.
Yeah. That's really cool, actually, the boiler thing as well, because, you know, these are little things that kill projects, especially in heat networks. You know, the biggest thing that kind of kills a lot of projects is when you put that O&M line into your project finance spreadsheet, you're like, what's the O&M going to be on this heat network? And it's like, well, what are the parts? I'm going to have to go out
really big.
And then it just, like, you pass that on to your consumer, and then it's like, why is this twice as expensive as me getting a heat pump? It's defeated the purpose of me doing this. And when you break it down, you're like, the energy charge is maybe 30% of what you're getting charged. Big charge of that is like 15-20% is now your O&M cost, because somebody's made a big assumption on what that's going to be, because it's quite a hard thing to O&M. So with tools like that, and actually being able to go backwards and look at, actually, what did we spend on O&M, or what does the industry spend on O&M, and then compressing that and having like a fair mechanism to charge, like, if it goes above X, then you have to pay for this, but the natural bill will be charged just what we think we need to do to keep you going.
That's why I think what you're doing at Gren's so interesting, because as you scale and do more and learn more, that, like, body of knowledge will only grow, and it feels like you're at the forefront of building, like, a very digital first, like, data first organization, which can't be said of a lot of the energy sector. Like, how do you think the pace of change is in the industry, and, like, what are we good at and what are we not so good at?
Yeah, it's this very interesting one. I think it's like, it's kind of like the last story in a sense, where because you're in this technical field, like, and I'll give you an example of these digital twins we've had to put into our power stations. Like, we had a bit of an incident where we ran before we could walk, had an Icarus moment, because we put the technology in, we started to utilize it a bit early, and effectively a few decisions led to a failure on the plant, which was driven by the digital twin. And everyone was like, you see, this is what happens. We're like, yeah. And then when we look back at the data, we realized, yes, there was probably some process, and we should have slowed it down to allow everybody to fully understand each parameter change that's going to be made. But at the same time, there was some underlying issues with the boiler. And I think where this gets to is kind of like, in the energy industry, you have a lot of very intelligent technical people who are doing very difficult things, like running a power station, understanding the thermodynamics of a combustion system, the fluid dynamics of a pumping system, but the chemistry of a battery system, like electrical engineering. Like, they're like, I'm doing such a complicated thing. How could this machine or this data help me? You know, I've studied for X amount of years, or I've been a technician for X amount of years. So there's this slight level of hubris thinking that I'm doing this really complex thing here. This digital system could no way help me to do my job. And it's not like one or the other. And I think that's one of the kind of risk problems in our industry. They put too much risk on, like, it's going to be too dangerous to do this kind of thing. And you're a bit like, well, again, just get started. You don't necessarily have to use all the functionality, like surface the data, look at the insights, and then make decisions like, yeah, it can't size my cable to go in here, but it can give me a bit of a fault study because it can see how much my peak electricity consumption is, and it knows what the generated characteristics are. So it can do one job for me, but the other 9 I've got to do. So I think that's a bit of the challenge of trying to get people to be open-minded and not too stuck in there. Like, and it's same for legal and commercial risk, where they're like, there's no way it could help write our contract. There's too many risks and regulatory things around it. It's kind of like, we need to be a bit more open and say, yeah, it's complicated, but it's not necessarily like brain surgery at that point. Like, it can help you do some stuff.
Yeah, and I talk to like the team a lot about like I think about like the 2 flavors of hard work, and you've got like quantum physics, complicated, or quantum physics is hard, right? And move 100,000 rocks is hard. And they're hard in very different ways. And we should be pointing the AI at moving the rocks. Yeah. Like, because it can do that pretty quick. Whereas we'll keep the quantum physics for us for now. Yeah. And like, people are like, oh, is it going to take my job? I was like, well, yes. If you can write down everything you do in your job, exactly. Yeah. I'll write you an AI that will take over. And like, people can't even write down what they've done in a day. Yeah. So I think we're safe for now. And that, I totally believe in what you're saying. Like, little bits, like pick off things, small wins, get the ball rolling.
But what's also interesting is reading a book called Utopia for Realists. It's quite an interesting book. I don't know what the author's called, but it's a super interesting book, actually. And it was just like, I just wanted to read something different, like not just business or like managerial or just like fictions. I was like, this is a bit of a out there topic. And one of the things you talk about is, if you look at the Industrial Revolution, there was like, I think it's like 100-fold new jobs. Even though like you had the mills and the pump replacing lots of old jobs, and like a lot of horses lost their jobs, but you had a lot more taxi drivers. You know, like there was only so many horse and carriage drivers, but there's so many more taxi drivers. And even with like new technology now, we're saying driverless cars, we'll lose all the taxi drivers wherever they go. But it's kind of like, well, there'll be a lot of maintenance on those cars. There'll be a lot of things that the machines won't do. So there is a truth of like, there will be a lot of job changeover, but I think we've got to get to the point of thinking about, all right, how do I leverage this to make me better and give me more chances to like study more, think more, be more creative, like think about actually what are we doing? Because we've got to a point where we're just doing stuff because we have to. Like, you get to work, answer emails, do this contract bit, do that design, go to that board meeting, make that presentation, do that bit of research, and then you're like, am I actually spending enough time? You're like, what am I trying to achieve here?
Oh, 100%. I talk like, what's the value add that you as a human, like with dreams and ambitions and like likes and dislikes, what's the value add that you are bringing to work? Yeah. It's not copying numbers out of that spreadsheet and putting them in that one. That's the bit that we should be getting the machines to do, all the boring stuff that no one, when they were 6 years old, got up and said, oh, what to do. So,
yeah. Even emails sometimes is just like, when you've got really, you know, it's hard sitting between a technical, commercial, and like sending emails to different audiences. Now I can write like my just core email and then say, okay, is this understandable for someone who's not technical, or is this understandable for not commercial? It's like, no, that's not. Use this phrase, like, thanks. Whereas before, you sit there like, has it taken me 45 minutes? Like, I've ruined my whole day trying to write this really good email to get it across because I don't want loads of questions. And now it's like 2 minutes, done. Great email, which everybody understands in clarity. And it's like, that's great for me because I've got like a little bit of dyslexia. So writing emails and stuff like that is way easier, and it makes it way easier to communicate really complicated stuff without wasting 45 minutes of my day, which can now be used for making nice coffees.
Yeah, too right. I kind of step further in that I can't stop talking. So I found there's a tool, Whisper Flow, and you install it on your computer and you can just talk into any text box on the machine. So I just talk to myself all the time, like, blah, 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 blah. And it runs, it doesn't just transcribe it, it runs it through a large language model that learns to kind of speak like you. So that Slack message, email, it's like, I'll just waffle for 10 minutes, and then it will just write this like well formatted bullet points, all that. It's really good.
Oh, wow.
It's a really good tool.
Yeah, I like that.
Okay, so interested to think about outlook, right? If we were to do another episode in 3 years' time, you come back to the Hypercube podcast when you've conquered Great Britain with heat networks. What would success look like for Gren and for you?
I think success for us would be Energy on Clyde is like a mainstay in Glasgow. And like people talk about it like the Armadillo or some of the other buildings. Like when people talk about it, it's like, oh, you connected to Energy on Clyde, and wherever our nickname's going to be, Costa del Clyde. I stole that from you earlier. It's just so hot in my house.
Yeah.
So, but that's where we want to be, where we've got like a big chunk of the infrastructure built. We're connected to some of the serious players. So hopefully we'll be working with like the local authority, working with the NHS, some of the significant industrial builders, and delivering heat and power. And like beginning then to start to say that now we've got that core infrastructure in, our two next steps are, how do we get a partnership of different heat users and heat network developers connecting into our assets and building their own mini heat network? And then how do we really start to leverage our kind of data platform to think about, okay, I've got all these thermal stores, I've got this power market that's moving up and down. How do I really leverage, the flexibility in the system to try to drive down my heat price, keep on driving it down, and really utilize heat when it's the best time to utilize heat, put power when it's the best time to utilize power. So I think we want to be in a space where we've got core infrastructure in the ground, and we're starting to really go into 2 levels of building partnerships with other heat network developers, power developers, and then really starting to really flex out the system so we can really deliver kind of like innovative heat network products that actually provide affordable, low cost, low carbon heat so everybody can connect, and working out how do we get like some of those most difficult like housing associations, how do we decarbonize them at a price that's like, yeah, that works for you, and you can help a lot of people who are in fuel poverty get out of fuel poverty at the same time as decarbonizing. So that's kind of the goal. And I think that's when we come back in 3 years.
That's not even that long a time frame to do all that, to like lay core infrastructure. Is that achievable? Do you think that's going to, how this will play out? You're going to have significant infrastructure in Glasgow in under 3 years.
Yeah, that's the plan. That's the plan. So we'll definitely in 2 to 3 years, we'll have our planning permission, have the core pipes and cables going in, and have the big connections ready, and hopefully we'll be ready to cross the river, because obviously we're on the south side of the Clyde, so we'll be coming north of the river. I think I've got that right. And so we're making good stead, and we're doing a bit of our first pipe digs in the next couple of weeks, actually, for Energy on Clyde. So we've kind of just said, look, we're going to open up the road, put the pipes in, and Evan Costner.
Yeah,
they will come to Gloucester than Clyde.
I love it. Amazing. Well, look, this has been a pleasure. I'm really excited to nerd out about heat networks, and yeah, you've had a really interesting career, and thanks for joining us here. Before we let anyone leave, we always like to just check if there was anything you would like to plug or promote, or if people in the audience want to find out more about you or Gren, where should we point them?
So if you search for Energy on Clyde, you'll go to the Gren website. I think it's definitely a good place to start there, and then get into the Gren universe from that point. I think we're doing some interesting stuff. We're doing a couple of events in the next few weeks trying to get into Glasgow. So definitely point them to Energy on Clyde and Gren.com to find out more about us. And then if you're in Glasgow and you want some heat, reach out to us and tell you when we're going to be in your area.
Look, it's been an absolute pleasure. Thank you again for joining us today. And yeah, all the best.
All right. Thanks a lot for having me.
As always, it's been a pleasure, and thank you for listening to the Hypercube podcast. If you want to find out more about what we're up to or meet other people in the space, join the Beyond Energy community, where data and energy professionals from across the globe collaborate on what's coming next. That touch.